Welcome to our webcast, Tips for Automation System Integration Project Management. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering. Don Roberts works with owners and senior management of hundreds of system integration companies, including facilitating strategic planning and executive coaching. He serves on boards of a number of companies and performs business-level audits globally to assess companies' compliance with the CSIA certification program. He served on advisory councils for several automation firms and one of Canada's leading high-tech universities, the University of Waterloo. He has regularly judged the Control System Integrator of the Year award contest as well. Dennis Brandel is founder and chief consultant of BR&L Consulting, Incorporated, specializing in helping companies use manufacturing IT to improve production, laboratory, and logistics processes. He's an active member of ISA 95 Enterprise Control System Integration Committee, co-author of the MESA B to MML standards, a member of the ISA 99 Industrial Cybersecurity Standards Committee, and is the former chairman of the ISA 88 Batch System Control Committee, contributor to the OPC Foundation and IEC 62541 standards, and has participated in the development of other industrial standards. His column on manufacturing IT and Control Engineering magazine covers IT aspects of critical modern manufacturing. He also regularly judges the Control Engineering System Integrator of the Year award contest. I'm Mark Hosky, webcast moderator and content manager for Control Engineering, covering system integration and other control and automation topics since 1994, and writing and editing about industrial technologies and topics since 1987. And now, Don Roberts' presentation.
Thanks, Mark. So here's what I'll be covering. First of all, should project management be handled internally, or is outside help needed? Then I'll move on to when's the best time to bring a systems integrator in to help with project management. And finally, we'll talk about looking at project examples of what you should do and what you shouldn't do to help minimize risk, including looking at different project methodology types. So let's start with who should manage my project? There's always going to be an internal champion that's responsible for the success of the project. But that internal champion may only be charged with sort of oversight or contract management and not the actual project management of the project. In most cases, the internal plant engineers are focused on operationally related issues and not so much on projects. I really like what the Project Management Institution's done with project management certification, and I really think the PMC certification is an important component. But when you get to systems integration projects, they're a little bit different than construction type projects, and PMP certification may not be sufficient. Systems integration projects have a lot more uncertainty in them, a lot of unknowns, especially around the software side of it. So even if a plant does have certified PMPs, that may not be sufficient background to be able to deliver a successful systems integration project. Another thing to consider, there are many plants that have no documented project methodology. They're in the business of producing products, and they're not in the business of actually doing projects. Certainly systems integrators' project methodology is core to what they do. And if that's the case, then for sure the plant would want to go outside for project management and look to a systems integrator. The other thing that systems integrators have found is that a single project methodology may not be enough. Some projects may follow a fairly straightforward waterfall type methodology, but others, projects that may need to be validated, for instance, would use a V-model approach and or a Gantt model approach. If the system that you have is doing automation of a test system or automating a new product or something of that nature, then you may find that what's necessary is an iterative methodology to work on your projects. Or even some of the projects that require multiple methodologies for different components of the projects. And I'll talk a little bit about that a little bit later on. But for instance, you might have a project where the software side of it is going to follow like an agile methodology, but the hardware, building the panels and all of that is going to follow a relatively traditional waterfall methodology. So when you're looking for an integrator, one of the things you want to do is you want to talk to them and say, do you have a good project methodology? Let's talk about the methodologies that we're going to use on this particular project. So we've gone ahead, we've decided that, this is a project that maybe we don't have the skill sets internally. We're going to look outside. We're going to get a systems integrator involved in the project. So when's the best time to get a systems integrator in the loop? Well, I'll tell you that you'll find the best time to get a systems integrator in is well before the project even gets started. These guys are experts at creating work breakdown structures, breaking the project down into the individual components so that they can accurately estimate those components and then ultimately, as the project progresses, manage to those individual components. It's also their business to stay on top of technology and technology developments. So when you combine the aspect that they could take a look at your projects and identify the best technology for your project, and they can structure the flow of the project in the best way for systems integration projects, that can usually yield some cost reductions. And so you pretty much want to have them early on the project so that they can have the maximum impact. One of the things integrators hate is being called late into a project after the project's already been started, kicked off, and there's really not enough money left in the project to do a good job of risk management and overall systems integration project management. So they really like being called in early and treated as a partner on the success of that overall project. One of the things that we're seeing that also impacts the project management is the overall downsizing of plant staff. So it used to be that there were a lot of plant engineers that could do the justification for projects, but that's rapidly disappearing. So again, it makes good sense to bring the systems integrator in early on, partner up with them, and the few dollars that you're going to spend up front with the integrator will save big dollars later on in the project, and certainly is going to reduce the overall risk of the project. When you're looking at an integrator, the other thing to consider is post-project support. So when we're talking about engaging the systems integrator, important to engage them early before the project gets kicked off, obviously throughout the project. But then when you look at the post-project, where oftentimes most of the money is actually spent, then who's going to support the overall system? Is that something that your internal maintenance people will do, or are you going to look to the integrator to be able to do that? So engaging the systems integrator early in the project, obviously through the project, and then after the project as well. So let's move on to aspects of risk and minimizing risk. It really is surprising the number of systems integration projects that get kicked off without a thorough understanding of the risks and how those risks are going to be managed. If you have a systems integrator partner that is engaged in the project and they haven't taken the time to sit down with you and talk through all the risks that this project could potentially run up against, then you might have the wrong partner. For instance, I wouldn't go in and talk to a surgeon about doing some surgery on me. If the surgeon didn't talk to me about the risks, I'd certainly go and find another surgeon. And to a certain extent, these systems integrators are doing surgery on your plant. So it's a good practice to talk about risks during the kickoff meeting, and then have risk conversations as a standing agenda on every status meeting throughout the project, and any status reports that occur during the project. These risks could come from anywhere. Typically, people are thinking about project risks from a technical perspective. But a good integrator is going to look at all of the potential risks. They may come from inside the plant, for instance, from access or safety or schedule, as well as the things such as overall technical risks. Another really big risk is not breaking the project down into manageable chunks. So if you look at your work breakdown structure and the chunks that constitute your work breakdown structure are hundreds or thousands of hours large, then that's an unmanageable project. It's impossible for somebody to estimate, say, a 1,000-hour task. Typically what people are going to do is they're going to take that 1,000-hour task, break it down into 10 or 20 tasks, and estimate 100 hours or 80 hours. And so if you look at your work breakdown structure and the finest resolution is 1,000 hours, 2,000 hours, 500 hours, then that's probably going to be unmanageable. You might find that certain aspects of a project also require one type of methodology, while others require a totally different type of methodology. For instance, if you had a project that was going to interface to a legacy system, sometimes it's good to just pull the interface component of that project off and run a iterative or prototyping methodology against that subset until you get that interface nailed down properly, and then reintegrate that part of it into a more traditional waterfall type project methodology. And then the other pretty important point is making sure that when you get into your project, early on in your project, you develop a project management plan. Now, a project management plan is a document that takes the integrator's project methodology or multiple methodologies, if that's what's going to be required, and defines exactly which tasks of that methodology are going to be applied on this particular project. So it customizes their general methodology specifically for your project. So project management plan is a pretty critical component to project management. Talked quite a bit about project methodologies, and I want to touch a little bit more on that. A couple of things about that represent a good methodology. First of all, it's important that functional requirements and risk management are done well. So your methodology should make sure that that happens. Additionally, it's important not to take shortcuts around project kickoff or formal closeout. Make sure that they get done every time. It's pretty critical to make sure that any questions that can be answered during the kickoff meeting are answered at that point. It's the cheapest time to deal with any kind of misunderstanding. If a misunderstanding shows up later on in a project, then the costs are significantly more. Similarly, for your project closeout, that's the point where you're going to want to make sure that every bit of your punch lists that are created, so that may be items that are identified during design reviews or factory acceptance tests or site acceptance tests, that all of those items are addressed and that the contractual requirements have all been met. You're also going to want to look during the project closeout to identify specifically when does warranty start, when does it end, and what kinds of support am I expecting to get during that period. So let me go back to the project kickoff, because there are a couple of points that I think are important to note for systems integration projects during the kickoff. One of them is software license transfer. So unlike a construction project, a systems integrator, when they start a project, if there's an HMI, for instance, involved in the project, the first thing they're going to do is turn that HMI on, and it's going to ask them to accept the license agreement for the underlying operating system. So they go ahead and press that. They're accepting that license agreement on behalf of the plant. So during the kickoff, make sure you clearly indicate to the integrator, if you accept any licenses, this is how, in our organization, we deal with software licenses. This is the individual or the organization that needs to be informed. Also, during kickoff, good idea to talk about acceptance points during your project. So on some projects, you may want to have a design review of drawings before they go to construction, a preliminary design review of software. You may want a factory acceptance test and a site acceptance test. So make sure all of that stuff is really clearly defined during the kickoff meeting. And also whether or not those are events that need to be signed off. So some methodologies are what's called gated methodologies. So for instance, there's a requirement for a design review When I get to the design review phase of the project is shut off. And there's no more progress on the project until that signature and approval is received for that design review. Others follow a more continuous flow where they get to the design review, they send the design out for review, but the project continues to move along. And in some cases, there's an assumption that if I haven't heard anything within 2 weeks, then I'm going to say that you're accepting that design review. Whatever it is, those are the sorts of things that you want to make sure you get clarified during the project kickoff. And then status reporting. Status reporting is fairly unique for systems integrator projects as well, and primarily because a very large part of a systems integration project is intangible. It's the software. You can't see it. If I'm in a construction project, it's pretty easy to tell when the foundations are done, when the walls are up, when the roof is on, and when I can start my fitting. But on a software-based project, it's a lot more difficult because the stuff is at best in a Word document, but usually it is just code snippets and things of that nature that you really don't have a good sense of it. So you're going to rely on the status report from the project managers to give you a sense of just how far along you are. It's one of the areas where that's less applicable is if your software portion of the project is following an agile methodology, because the agile methodology has built into it the concept of status reporting every morning. A couple of other unique characteristics for systems integration projects. Change orders. Change orders happen on every project. If I'm building a house, there's going to be change orders. If I'm building a very large, complex system, there's going to be change orders. The unique thing about systems integration projects is that those change orders may not only influence where the project goes from here, but also could have an impact on things previously already agreed to. So, for instance, if I was checking out a software module and I decide that I want to change the functionality of that software module, and the project is a validated project, then I may have to go back to the functional specification document and change that so that it aligns with the new functionality I define. I may even have to go back to the user's requirements document, or I may have to go back to an acceptance test plan. And the reason for that is in a validated system, when I do my final test, I need to test the system against the functionality defined in the functional spec. So there's a couple of aspects of change orders within systems integration projects that are unique. I want to touch a little bit on configuration management. Systems integration is the process of pulling together a collection of things into a functioning system. Those things are things like software, hardware, processes, and production materials, tools, a good collection of them. The configuration of this collection of things then changes as the project proceeds. So let me put that into a little bit of perspective. Think of the difference between a set of drawings that is released for construction versus the set of drawings that is the as-built set. When I create the set of drawings to release for construction, I have a whole big stack of drawings, each drawing at different rev levels, but the collection of all of those drawings then forms a configuration that's released for construction. The thing gets built, goes out into the field, gets installed, and then the as-installed or as-built version, some of those drawings are going to change. So the revision numbers on the drawings change, and I have a whole new collection of a whole new configuration, which is called as-built or as installed. The same sort of thing applies across things like software, where software builds, or hardware if I'm doing traceability on individual hardware components. So think about configuration management. Whose configuration management are you going to use? Is it going to be yours? Is it going to be the configuration management system that the integrator has? A really big area is the next one, intellectual property. Your systems integrator is going to come to the table with a lot of reusable code, project methodologies, and systems and processes that they've built over the years, and this is representative of the collection of all their knowledge. They're going to want to continue to own that, and they need to continue to own that. The plant, on the other hand, is going to bring to the project maybe some process knowledge, maybe even some proprietary process knowledge, and they're going to want to continue to own that. So early in the project, you have to define who is going to own what aspect of the deliverable of the solution. And as I said, usually the systems integrator is going to peel off all of those things that he needs to continue on in his business, and he's going to continue to own that, give the plant rights to use it, copy it, reuse it, whatever, but he's going to continue to own it. So intellectual property, pretty big topic area. Finally, maintenance. When this new system goes in, it's undoubtedly going to be newer technology, possibly even newer programming techniques. So how is the plant going to maintain that project as it after it's completed? Are you looking to the integrator to provide training for that, or are you expecting the integrator to actually provide 24/7 support for some time into the future? So all important things to take a look at as a project manager. I want to shift a little bit here and talk about some of the different aspects of project management. So we're starting to see more companies realize that there's three aspects to project management on a systems integration project, and that each of those three aspects require different skill sets and oftentimes different personality as well. So we've been talking a lot about project management here, but the size of the project, as the project grows, the project manager is going to be focused more on things like budget and schedule and overall quality, and will have less time to focus on the technical solution. And as that happens, that's when there's a need for a thing called a technical leader, someone that's coming in and making sure that the solution is actually going to do what you expect it to do. These are both very detail-oriented people and hopefully highly structured. They're just focused on different aspects of the project. And one of the things that systems integrators find is that a good technical person doesn't necessarily make a good project manager. What happens is as the project gets more intense, they tend to focus more on the technical side of it, and the project management sort of drops off. So while these two individuals are filling the roles that and they're flat out on the project, then what happens is the customer side of the project often suffers. So there's this new concept, this sort of third leg of the stool of overall project management, and that is the customer relationship manager. So think of this role as being somebody who is the customer's advocate on the project, making sure that the customer is leveraging the full capacity of the systems integration company and getting the maximum benefit of that partnership. So during your kickoff meeting, it's important that you document who's going to be filling each of these roles, and there's a clear understanding of what that role is. It may be one person filling all three roles, it may be two, it may be three different people. So those are some of the things. I think if you follow these areas, you're going to do a great job of managing the risks on your projects. And with that, Mark, I thank you very much for the opportunity to present.
Thanks, Don, for the great information. We'll show his contact information again at the end during the Q&A session. You can submit any questions for Don now in the Ask a Question console, and please start the question with Don's name if the question is for him specifically. And now, Dennis Brandel. Dennis?
Thank you, Mark. What I want to talk about today are basically a couple of the activities that you do at the start of a project and one that you can do at the middle or the end of the project. And as we look at integration projects, one of the big questions that comes up at the beginning of these is if you really do need to do a redesign as a result of doing this integration and applying automation into a system, or whether or not you can use the existing systems that are in place. It's often a critical question that you do want to ask at the beginning of a project because it can set the whole direction of what the project is and where it wants to go. The second thing we want to talk about is some of the project management styles that are going to be involved in influencing the decisions you make and how you want to progress. Simply because when you're doing integration projects, you're oftentimes dealing with multiple different organizations, ones that you don't really have control over, so you really want to make sure that you have some visibility into what they're doing and how they're doing their jobs because they are going to impact your schedule. And then finally, something that unfortunately too many of us often have to look at is this project beyond help and it needs to end? It's an unfortunate event, but the statistics show that many software projects fail, many integration projects fail, so a significant fraction of them will fail. And you need to know if you are in one of those projects. So those are the things that I want to talk about today. First one is, should you automate or redesign your project? Basically, this is a choice you have to make at the beginning of the project as you look at the different systems you're trying to work together. Do you really just want to pave the cow path, take the old designs that existed and try and mash them all together? Do you have many touch points that you want to look at? Some of these systems you may be integrating may be very old. They may have very limited access points. You may be trying to integrate a system from a PLC that's no longer available to an operating system that's also no longer available, but you have to integrate those two together. And you have to look at it and say, okay, is it more work to actually integrate these, or should I redesign and re-implement part of this as part of this integration project? Some of these systems that we'll be looking at, they have built-in integration like at OPC and Profinet and Ethernet IP available. Others may just have RS-232 connections, and you have to send it text and simulate somebody actually typing in on a keyboard in order to get integration into it, as well as many systems, unfortunately, are really designed with poorly structured code because we don't oftentimes have a lot of software engineering expertise involved in designing systems, especially if they're older systems that we really wanted to integrate together. So how can you tell whether or not you need to redesign or whether or not you can use the existing design? And there are a couple signposts you can use. There's no absolute big flashing sign that says redesign on it, but what you can do is you can look at the characteristics of the systems that you're using, and from those characteristics you can determine whether or not you really need to do some sort of redesign. Some of those characteristics are rather obvious. If there's no design or testing documents for the existing systems, then you have to consider the fact that you are going to have to re-implement the designs, re-implement the testing. Oftentimes, if the systems are old, the documents may have existed, but you may not even be able to actually find them now. So you have to look at the fact is, if I have a system in place that's running and I don't have any design documents and I have to do an integration on it, again, it may be less work to re-implement that system, re-implement the PLC code if possible, re-implement the HMI pieces of it, re-implement the other pieces, because it's going to take a lot less work. You can tell if that's going to happen because many times these systems have a little "don't touch it because you're going to break it" sort of sticker that's on it, or at least everybody knows that that's the case, because it may be based on some obsolete language that's out there. So for example, let's say it was all done in Turbo Pascal, or you may have obsolete technologies that are out there. It's all Windows 95. And have an environment where you can't even build a test bed because the hardware is so obsolete and the software is so obsolete. In that case, again, you have to look at it and say, well, it may be faster, it may be better, and a better solution for the end user to simply say, we're going to re-implement and redesign this system rather than try and integrate together into things that were never really designed that way. As you look at the integration too, I think one of the other big keys that come out of this is to look at all the interfaces that you are going to need to tie those pieces together. I've seen on software projects and integration projects where you have lots and lots of little interfaces where you have to send something, then get something back, and send something and get something back. I do 5 or 6 exchanges, all of which have to be synchronized and serialized in order to get one thing done. Maybe I need to download a new picture into a vision system, and I got to do it in 6 different steps because there's no real interface available to do it in one simple thing. Well, the more those little interfaces are, the bigger the integration project cost is going to be. So you really do want to look at those carefully and see whether or not you need to do a redesign there so that they aren't so tightly coupled together. Then finally, on older systems that haven't really ever been designed for integration, there's no obvious integration points. What that means is you really are going to have to go in there, look at what's going on inside the code and inside the system, and from that figure out exactly how you're going to integrate it together. If you don't have the design documents or the testing documents and you're going to be reading people's code, you hope that they have commented their code, but unfortunately, again, that's not a common occurrence, especially on older systems. So when you take a look at all these things together, these give you the signs that tell you whether or not you need to redesign, because each of these problems that show up are really problems that are going to cost extra time and money. And if it's going to take more time and effort to actually do the integration than it would be to do a simple redesign with integration in mind, then that's when you need to do the redesign. And this is something you do very early in the project as you're starting to look at how you're going to address this. And you need to make sure that you work with the system owners, because you may have to tell them this system was not designed to ever integrate together. We really do need to do a redesign on it. They may have to come back and say, yeah, well, okay, well, we need to make sure that we add validation and other pieces in place to make sure that the system that we're re-implementing performs the correct functions and does what the old system needed to do. So once you've gone through those, then you have to consider the next problem, which is you're not really in charge. You know, project management styles, a lot of us as project managers, as engineers, we want to be in charge of a project. Yet, in an integration project, you will invariably be dealing with multiple different groups that are out there. Many times in integration projects, you may be dealing not with just the system owners, the people who have responsibility for the PLC or the HMI or the MES or the batch system or any of these other types of systems, but also the people associated with providing networking services, because these things all have to sit on some sort of network. Generally speaking, integration projects today move to an Ethernet or a TCP/IP-based integration, so you've got to work with the network people. You got to work with the security people, because you've got to make sure that the switches and routers have the right settings set for it. And that may be a different group. And you may have to work with a database group, because you're creating a database as part of your integration project. And that oftentimes is a whole another group. And then you look at the fact you may have to add some servers. You may have to add some computers to the system to do the integration, and that may be a whole nother group. As a project manager, you're in the position where basically you don't have a lot of control of what's going on. You really have to develop that flexible schedule that allows these multiple alternatives and delays that are built into the system. And you have to plan for these very, very, very early on. Because if you don't plan for them very early on, what's going to happen late in the project is suddenly things will stop working. You'll have it working in a test environment, you put it into the production environment or the simulated one, and suddenly you realize that the whole security group never got talked to, and you cannot create the accounts that you may need, or you cannot set up the firewall rules and the security rules and the router rules. Or you talk to the networking people and they say, oh, well, we don't have any ports on our switches. We need to add a whole new set of switches, and that's going to take us 6 weeks to do. Or if you're not using virtual machines and you have a database and a set of servers, they may come back and say, hey, yes, we can do that, but it's going to take us 2 months. And then if you don't have those built into your schedules, you're going to have a real problem associated with trying to get a lot of this done. But there is a way around this, and it's really, there's some little acronyms here that I use, some little memory mnemonics to help make this a little bit easier. And the first one, what you want to do is you want to set an anchor, you want to set something firm in the ground with all of these service providers that are in there. And you do that in a couple steps. You have to give them advance notice that you're going to be doing this. Now, this advance notice is not necessarily the firm order for the service, but it is talking to those different service providers, the network providers, the security providers, the database providers, the server providers, talking to those people and telling them, we have this in place. We are going to be doing this project. We're going to need some of these pieces in place. In the advance notice time, what they will tell you is what their schedules are, when they may have, what their priorities are, how much lead time they will actually need to get something done. And you can also ask them and find out, okay, how reliable are you on getting your estimates? Are they realistic? So you do advance notice to these organizations, and then you continue to checkpoint on these as you continue to do your development. When you reach their time fence that says, okay, now we can formally order the service because they can put it on their calendar, and let's just say they say, we don't want to, we do not want you to tell us anything that's going to happen 6 months in the future. You tell us a month before we need it, and then we'll get it there. So you make sure you put into your project calendar that you will order the service at the time that they have set it. So now you've kind of anchored in all your service commitments with your advance notice, the checkpoints prior to make sure that their schedules haven't changed, their priorities haven't changed, and now you formally ordered the service. Okay, and now you want to steer this ship forward here, which means now you can set up your schedules because you have the schedules from the service providers. You can talk to them on a regular basis, and this is extremely important, something you have to do because their schedules may change and their priorities may change. You may think you're at the top priority for them, but if something happens, if they're also supporting operations inside the facility, they're going to come back and they're going to say, okay, we've changed it, so now you have to be flexible on your schedule. Then you want to execute the service, you want to analyze the results, and unfortunately repeat if needed because many times as you're working with service providers like this, whereas you have specified something, what you finally get many times may not be exactly what you ask for, particularly in the security area because there's so many security rules and firewall rules and other rules that you may not be aware of that they have put in place that are going to impact you, impact your ability to do communications. I've seen systems in place where people put in the default servers and default databases, all of which are much too small for what the projects actually are. So you really do want to go back and repeat if necessary to make sure that they're giving you exactly what you want, and you really have to be flexible in these whole decisions. Now, the really hard one is to knowing when to stop or when to reboot this project. Unfortunately, many people have been involved in failed projects, but when you look at it statistically, there's a large percentage of projects that actually fail. And they can fail for multiple reasons. The primary reason being they don't actually meet the requirements. Other reasons are they just keep going and never seem to stop. I've seen projects that are supposed to be 6 months long and 3 years later they're still going on because it's really hard to stop a project. And if you wait too long, you end up with this gambler's dilemma, which is I've already invested so much money into this project. How can I justify stopping this project at all? And that's a kind of a political decision that you really have to do. But it is an important thing to look at to say, okay, are we in an integration project where basically we got to reboot? The path that we have taken, the design we have taken is no longer valid, and we really do need to do something else in order to move forward on this. The reason we get in this situation is that people are consistently optimistic. We all overestimate the probability of success and underestimate the probability of failure. As engineers, we are probably more prone to this than other people because we know we never fail. Yet, many times, 10 to 30% of software projects will fail, and I'm giving you a very optimistic account of that. I've seen other statistics which say 40 to 50% of software projects actually fail. But even though we know that, it's impossible for us to really apply that to each individual project. So let's just say, just as an example, you're working on a project. What if you were to do that project 10 times? And you intellectually were to know that 2 out of those 10 times it's going to fail. Would you be able to identify that? Would you be able to stop and reboot that project early enough to get it done? Well, there are some signs for that that you can use to tell you whether or not that project is failing. And the signs are pretty obvious signs. Again, you have to look at it and say, okay, do we really have no architect or architectural team? If you have a project manager out there and who basically says, okay, I just want to see the code. Just make sure that I get the coding done, and you give the task to the coders to develop the system without an architect or an architect's design, you're really not going to know what you're going to end up with, and chances are it's not going to work as expected. no firm schedule. I've seen projects where basically the schedules change every week, and if you're in that mode where you basically say, okay, we're a week later and the schedule just slipped one more week, you're in a position to say something's wrong with this project. I need to reboot it. I'm not going the way that I should be going on this project. Another failure mode that I've seen oftentimes is using the wrong tools for the tasks. I've seen so many schedules that are maintained in spreadsheets instead of being maintained in specific project management tools or simple sort of scheduling tools. They just spreadsheets. People can't maintain them. People don't maintain them, I should say. You don't have the visibility. You don't have the ways of looking at the critical paths. You don't have ways of looking at resource allocation and all the others. Task lists are in documents instead of some sort of project management system. And worst case, designs are in presentation files. I call those, these aren't really architectures at this point in time, but many projects will basically say, oh, the architecture is defined in this PowerPoint presentation. That's a sure sign that you've got a problem on there. A project mentality of failure is not an option. Now, this is a little controversial because from a strategy standpoint, failure is not an option is a good strategy, because you may be on projects that say this has to work. If this doesn't work, our plant will shut down. But from a tactical standpoint, on the project level, it's really a failure, because it means you can't afford to fail. That means you can't make any mistakes at all. So you end up with paralysis by analysis, where nobody wants to make a decision because it is a problem. There are a couple other things that are out there looking at the project management or the configuration and source code control, the no documentation on the system, design and test documents not up to date, changing requirements. All of those are signs that you really are on a failing project. Now, a common tactic on this project is to stop the project, declare success, change the requirements that you can't meet, reissue the requirement documents, and walk away from it and say, hey, yes, it was our successful project. But in your heart, you know it really wasn't. The problem with approaching this on a project is that you don't really learn from past mistakes. So if you want to make it very obvious, you want to come out and say, look, this project failed. We met 80% of our goals, or we met 70% of our goals, but we need to learn from that. We need to go back and say, why did we do it this way? So those are the things to look at as you're working on a project. Remember, sometimes you're going to have to redesign the systems, or some of the systems, oftentimes because they're old, they're obsolete, they're using obsolete languages. They may be using languages that nobody understands anymore, or nobody even knows anymore, because they're 20 or 30 years old. They may be using systems that are 15 or 20 years old you can't buy anymore. You can't even go to eBay to buy them, so you need to look to do redesigns there. Make sure on your integration projects you're aware of all those external organizations. Make sure you anchor in their commitments, and then you steam forward or steer forward to finish your projects. And then look for those warning signs of impending failure and rebooting if you need to. Okay, thank you.
Thanks, Dennis, for the useful information. We'll show Dennis's contact information again at the end during the question and answer session. You can submit your questions for Dennis or Don Roberts, the first speaker, now in the Ask a Questions console. Please start your question with their first name if the question is for one person specifically. And now I have a few slides about system integration research before we get to that Q&A session. The learning objectives that I'll cover, I'll be looking at system integration research as it relates to project management. I'll quickly cover the methodology of our research, look at when system integrators usually join a project versus when they should, and then cover system integration project effectiveness and related measures. So we conducted this research to better understand system integration of devices and systems as it applies to controls on automation and instrumentation from the perspective of the system integrator and the engineer hiring the system integrator. The sample was selected from recipients for whom we had emails. The survey was open from June 6th through June 19th of 2014. There were 278 qualified recipients and a margin of error of around 6% at 95% confidence level. these results look at the timing for a system integrator. The darker top bar in the graphic shows when a system integrator should join a project. The second lighter bar shows when a system integrator usually joins a project. So nearly 60% of the respondents think that system integrators should join a project at either the project inception or for the entire life cycle. Project inception was the most important single answer. Survey respondents also reported that system integrators typically join the project in the design or specification phases, not optimal. Here on project effectiveness, we found that 9 out of every 10 respondents rated the automation system integration in their facility or the facilities where they were involved as either highly or moderately effective. Now, looking at that another way, less than half considered the automation system integration being performed as highly effective. Now, that would include in-house system integration efforts as well as hired system integrators. We didn't break them out. On the right, the leading measures of project effectiveness were listed as budget, on time, and productivity. Note that return on investment was 4th on the list. Thank you to our research director, Amanda Pelliccioni, for this report, which is expected to be updated later this year. So now we have a Q&A session. As the audience listening live can type in questions for today's presenters in the Ask a Question box on the screen, we'll answer as many as we can. Within a few days, the presentation will be available for on-demand viewing along with a link to the quiz for potential PDH credit. We'll post the archive on the Control Engineering website and send you an email message with a link connecting directly to it and related resources after it's ready. If you contact any of the speakers here directly via the email on the next slide, please reference this webcast in the subject line to help ensure that we all can recognize the email in the correct context. And now on to the questions. So the first question is, among the list of project failures, Don, what are the top 3 things that scuttle automation projects?
Well, I think that the top 3 things, in the order that I would pick them, is inadequate conversations around risk, where the integrator and the client didn't really understand all of the risks, or they weren't both communicating the risks, and then also managing those risks throughout the project. The second would be just general communications. I see all too many projects where they may have a kickoff meeting, and the next time they talk to the customer is when they're delivering the solution, and there's a lot of surprises. So it's really important to set up a good communications structure and manage each other's expectations as the project goes on. And then I would say the next biggest one is really getting caught in the trap of using the latest technology. So a lot of the plants are being pitched to by vendors of the latest in technology, and I think that the integrators will tell you that you want to be off of that bleeding edge a lot of the times. You just maybe leading edge, but not bleeding edge. So I think that incorporating some of the latest technology is the third one. I would, if I get the option of a bonus, I would say the 4th most common thing is we talked a little bit about roles earlier on, and I think not clearly understanding the requirements for each of those individual roles it leads to the project failures.
Great, thanks. Dennis, here's one for you. How will the Internet of Things change automation system integration project management, if at all?
Yeah, that's an interesting question, because the Internet of Things is the big hot buzzword today. And the Internet of Things essentially means that every device, everything out there is smart, and everything out there talks, and generally talks across some sort of TCP/IP network. What will happen, I believe, as we talk about the Internet of Things, is we're going to have a whole lot more set of service providers that we're going to have to work with to integrate these pieces together. If every device is speaking on the network, that that means that the people who are doing the network management and the security are going to be very heavily involved in getting this project in place. We'll need many more switches, many more routers, many more connections, or if they're wireless connections, you've got to make sure that you're going to have the wireless system set up in place. So I think what will happen is there's going to be more and different organizations within your company that you're going to have to coordinate with as you start to work this out. And some of those are going to be very interesting discussions as you move to wireless technology, and maybe you need wireless technology for the devices that are out there as well as some of the handhelds that people in your plant are actually using, and your corporate standards may not actually allow that or may not even talk about it yet. So that's, I believe, the big thing that's going to happen with the Internet of Things. Many more service providers, internal service providers, and maybe external service providers you're going to have to work with on your integration projects.
Great, thanks. Don, a question on time management as we're trying to hurry to get in a few more questions. How do you set the time of each variable in a project to ensure that you complete the project on time? And if you're running late, how do you get back to the target date involved?
Yeah, I touched a little bit about that on work breakdown structure. So make sure that your work breakdown structure is reduced down to chunks that are manageable. And by manageable, I mean like 80 hours maximum. If you go to Wikipedia and look up work breakdown structure, particularly the North American version of Wikipedia, they give you some good guidelines of, this is pretty old technology. It's been around, proven, and it gives you some good guidelines around how you would go about doing that. But if you haven't got it broken down to find enough components, you're not going to be able to manage it.
Good, thanks. Dennis, one for you. How do you decide if an implementation should proceed in small steps or full system integration all at once, very quickly?
Very quickly, if you don't have the capability of building sandboxes and doing test cases, then you have to go all at once. But if you have the capability of building any sort of sandbox and test case and simulating the environment, then you want to do this in smaller steps because you're going to find out if there are problems early on. And that's really the simple answer to it. If you have the choice, do it in small steps. If you don't have the choice, then you're going to have to do the best you can to put it all in at once and do a big bang integration, not its preferred solution.
These were excellent questions, and we have many more that we're going to try to get to offline and then post the answers with the archived webcast. So I'll thank again our great speakers, Don Roberts and Dennis Brandel, for sharing their time and expertise today.